Divya, Assistant Professor, Department of IT. The topic to be covered today is sorting algorithms. Sorting. What is sorting? Sorting is arranging data items in any order. The order can be from lowest to highest or from highest to lowest. That is ascending or descending. Where are we using these sorting algorithms? Where we can access the files. For example, in our computer, we'll be having some files that is stored. So normally we used to take it as sorted order. Right? For example, sorting in the order of date or sorting alphabetically likewise. So day-to-day life we are using these sorting algorithms regularly. Or you can using from students arranged for a lab session likewise. Types of sorting. We have two types of sorting. One is internal sorting and another one is external sorting. Internal sorting is we are arranging the data items within the space provided. For example, when you have array of data items, we are just swapping or interchanging within the same array. Those algorithms are taken as internal sorting. When you come to external sorting, not only the space provided, we are taking some other spaces that are allocated and we are using the sorting algorithms. These are some of the sorting algorithms we are going to see. Bubble sort, selection sort, insertion sort, shell sort, quick sort, merge sort, radix and bucket. These 5 sorting algorithms are coming under the category of internal sorting and the last 3 algorithms are coming under the external sorting. Bubble sort. So to start with a simple algorithm, bubble sort. What is bubble sort? The name itself says bubble. For example, when you have a bubble in a bucket, it will just come to the surface. The same manner, when you have a set of data items, the largest data will bubble. That means if it is in anywhere position, it will just bubble and come to the last position. The second largest element will bubble and come to its second largest position. That is the algorithm. So to see with an easy example, when you take this data items, the first element taken is 7. It is compared with the nearby element. So the bubble, how it will not come as of sudden to the surface. It will just replace the next water level and just it will come the same manner. The largest element will be compared with the next element and that element will compare to the next element. It will be just bubbling. So here if you take the 2 is smaller than 7, so it is bubble. When it is compared with 8, the 8 is the largest. So now I am taking the 8 to be the largest. So that now 8 will bubble. So it will compare with 5 and it will be compared with the last element 4. So this is the first pass. Every algorithm will be having passes. That means the number of steps to be repeated again and again. The first pass will be having the highest element in the last position. When you come to the second pass, we will be taking as usual you start with the first position. This is the main concept of bubble sort. Always you start from the first, you compare with the nearby element. If it is largest, it will just swap. Otherwise, you go to the next element. So if you come to the last position, again in the next pass, you just take the first 2 elements, the same thing is repeated. Here when you take 8 is already sorted. The next element to be in position is 7. This is the second pass. When you come to the third pass, the first 3 elements are taken and the third largest element is bubble. Then we have this thing. Okay. So when you take number of elements as 5, here the number of passes is 4. So number of elements n, the number of passes will be n minus 1. So this is a simple algorithm. You can implement in C, C++ or Java or any programming language. So when you take this outer loop is for taking the number of passes. This loop is for comparison. So here if you take this, the steps is comparing the nearby elements. If the nearby elements is greater, you just swap it. Otherwise, you go to the loop. So this is the main concept of bubble sort. The next easy sort is insertion sort. The word itself says insertion. So here we are finding a particular position where the element to be inserted. We are taking the element, we are inserting in the position. This is the basic concept of insertion sort. So to easily understand the concept, here we can take an easy example, playing cards. For example, when I have 4 cards in my hand, automatically when the new card is dealt, what you will do? When I have the cards in my hand, what I will do? I will just move the position where the actual card to be inserted. For example, I have to insert 12. Already I have the cards. 6, 10, 24 and 36. So I will compare the last element. If it is greater, I will move that. So I can insert here. But again I will insert, I have to select the previous element and compare. This is also highest when compared with the new element. So I just move. Here the position is free. I can insert the new element. So this is the concept of insertion sort. So when you take this insertion sort, main thing is when you have n elements, the number of passes will be n minus 1. So if I am in the nth pass, for example, if I am in the fourth pass, fourth iteration also can be said. Fourth iteration, 4 elements will be already in sorting order, will be taking the fifth element, right? So to simply put it in the manner, we can have n elements, n minus 1 passes. Every mth pass, already m elements will be ordered. M plus 1th element will be taken and inserted in the position. So this can be taken with the number of elements. If we have just 6 elements, for example, I am in the second pass. What is the meaning? Already 2 elements are sorted. I am taking the third element. I am finding the right position to be inserted. I am comparing with the last element. It is highest, it is moved. The new space is found and I am inserting. So here I can easily explain. 5, 2. So 4 is inserted and it is moved. So here the same manner the elements are inserted in the previous element. So this is the insertion sorting algorithm. So here the outer loop is as usual for number of iterations. The number of iterations starts with 2 to n. If you take the bubble sort always the iteration starts from first element to the last element. In insertion sort the pass starts from the second element to the last element. Inside the loop what you are doing, you are just comparing the last element in the already sorted elements. So you are just comparing with the previous element, you are moving. So this is the done in here. So the element to be taken is, so for example, when I want to take 6 and insert here. So this element is taken as the key, right? So insert this A of j in, I am just moving. So this is taken up to previous elements. So it is 1 to j minus 1. Here the loop, this while loop is taken for comparing with the key element. So if the key element is smaller than the taken element, the element compared should be moved. So that is done here. So in that way the insertion sorting algorithm works. Okay. So today we are just seeing 2 algorithms, bubble sort and insertion sort. The next algorithms can be seen in the next video. Thank you.